Question 1. Find the LCM of the smallest two-digit composite number and the smallest composite number. Here are the options. The smallest two-digit composite number is 10, which is 2 times 5. The smallest composite number is 4, which is 2 squared. The LCM of 10 and 4 is 2 squared times 5, which equals 20. The correct option is C, 20. Question 2. If alpha and beta are zeros of the polynomial f of x, and alpha plus beta equals alpha beta, find p. Here are the options. The sum of zeros, alpha plus beta, is 2 over p. The product, alpha beta, is 3p over p, which is 3. Given the sum equals the product, 2 over p equals 3. Therefore, p is 2/3. The correct option is B, 2/3. Question 3. Find the value of k for which the system of equations has infinite solutions. Here are the options. For infinite solutions, the ratios of coefficients must be equal. 1 over k plus 1 equals k plus 1 over 9. This implies k plus 1 squared is 9. So k is 2 or negative 4. Checking the constant terms, k equals 2 satisfies the condition. The correct option is A, 2. Question 4. If the roots of the quadratic equation are sine alpha and cosine alpha, which of the following relations is true? Here are the options. The sum of roots is negative b over a, and the product is c over a. Squaring the sum equation, we get sine squared plus cosine squared plus 2 sine cos equals b squared over a squared. Substituting the identity in product, we get 1 plus 2c over a equals b squared over a squared. Simplifying, we get b squared minus a squared equals 2ac. The correct option is C. Question 5. In an arithmetic progression, if the common difference is negative 4, number of terms is 7, and the naughth term is 4, find the first term A. Here are the options. Using the formula for the naughth term, an equals a plus n minus 1 times d. Substituting the values, 4 equals a plus 6 times negative 4. This gives 4 equals a minus 24. Solving for a, we get 28. The correct option is D, 28. Question 6. The sum of the first n terms of an AP is given by 3n squared plus 6n. Find the common difference. Here are the options. First term a1 is S1, which is 9. The sum of the first two terms S2 is 24. The second term a2 is S2 minus S1, which is 15. The common difference D is a2 minus a1, which equals 6. The correct option is A, 6. Question 7. The graph of a polynomial cuts the x-axis at 3 points and touches it at 2 other points. Find the number of zeros. Here are the options. The number of zeros is the total number of points where the graph intersects or touches the x-axis. Here, it cuts at 3 points and touches at 2 points. So, the total number of zeros is 3 plus 2, which is 5. The correct option is C, 5. Question 8. In which quadrant does the point dividing the line segment joining 7, -6 and 3, 4 in the ratio 1:2 lie? Here are the options. Using the section formula, the x-coordinate is positive 17 over 3, and the y-coordinate is negative 8 over 3. Since x is positive and y is negative, the point lies in the fourth quadrant. The correct option is D, fourth quadrant. Question 9. Find the distance of the point P2, 3 from the x-axis. Here are the options. The distance of a point from the x-axis is given by the absolute value of its y-coordinate. Here, the y-coordinate is 3. So, the distance is 3 units. The correct option is B, 3. Question 10. In triangle ABC, D is parallel to BC. Given the segment lengths in terms of x, find the value of x. Here are the options. By the basic proportionality theorem, add over dB equals A over AC. Substituting the expressions, we get x over x minus 2 equals x plus 2 over x minus 1. Cross multiplying and simplifying, we find x equals 4. The correct option is A, 4. Question 11. Two concentric circles have radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. Here are the options. The radius of the larger circle is the hypotenuse of a right triangle formed with the radius of a smaller circle and half the chord. Using Pythagoras theorem, half the chord length is the square root of 5 squared minus 3 squared, which is 4. The total length is 8 centimeters. The correct option is A, 8 centimeters. Question 12. If tangents PA and PB are inclined at 80 degrees, find angle PA. Here are the options. The angle between the radii is supplementary to the angle between tangents. So angle AOB is 100 degrees. Triangles PA and POB are congruent. So angle PA is half of angle AOB, which is 50 degrees. The correct option is A, 50 degrees. Question 13. If 4 tan theta equals 3, evaluate the given expression involving sine and cosine. Here are the options. Divide the numerator and denominator by cosine theta to express terms in tan theta. The expression becomes 4 tan theta minus 1 over 4 tan theta plus 1. Substituting 4 tan theta as 3, we get 2 over 4, which simplifies to 1/2. The correct option is C, 1/2. Question 14. Find the value of the expression involving sine and cosine of 30 and 60 degrees. Here are the options. Substituting the standard trigonometric values, we see that sine 30 equals cosine 60, and cosine 30 equals sine 60. The terms cancel out perfectly, resulting in 0. The correct option is B, 0. Question 15. If sine alpha is 1/2 and cosine beta is 1/2, find the value of alpha plus beta. Here are the options. Sine alpha is 1/2 implies alpha is 30 degrees. Cosine beta is 1/2 implies beta is 60 degrees. Their sum is 90 degrees. The correct option is D, 90 degrees. Question 16. If x equals a cos theta and y equals b sin theta, find the value of b squared x squared plus a squared y squared. Here are the options. Substitute x and y into the expression. We get a squared b squared cosine squared theta plus a squared b squared sine squared theta. Factoring out a squared b squared, the remaining trigonometric identity sums to 1. The correct option is A, a squared b squared. Question 17. If the perimeter of a circle is equal to that of a square, find the ratio of their areas. Here are the options. Equating perimeters. 2 pi r equals 4 So equals pi r over 2. The ratio of areas is pi r squared over a squared. Substituting a, we get 4 over pi, which simplifies to 14:11. The correct option is B, 14:11. Question 18. A solid sphere of radius r is melted into a cone of height r. Find the radius of the cone's base. Here are the options. Equating the volumes. 4/3 pi r cubed equals 1/3 pi r squared h. Since h equals r, we simplify to get r squared equals 4r squared. Thus, the base radius r is 2r. The correct option is A, 2r. Question 19. Assertion. The probability that a leap year has 53 Sundays is 2/7. Reason. A leap year has 366 days. Here are the options. A leap year has 366 days, which is 52 weeks and 2 extra days. These 2 days can be any of 7 consecutive pairs. 2 of these pairs contain a Sunday. Thus probability is 2/7. Both statements are true and the reason explains the assertion. The correct option is A. Question 20. Find the sum of lower limits of the median class and modal class for the given distribution. Here are the options. The total frequency is 66. The median class corresponds to the cumulative frequency greater than 33, which is 10 to 15. Its lower limit is 10. The modal class has the highest frequency 20, which is 15 to 20. Its lower limit is 15. The sum is 25. The correct option is B, 25. Question 21. Prove that 5 minus 2 root 3 is an irrational number, given that root 3 is irrational. Let us assume that 5 minus 2 root 3 is a rational number r. Rearranging the equation, we get root 3 equals 5 minus r divided by 2. Since r is rational, the right-hand side is rational. However, the left-hand side, root 3, is irrational. This contradiction implies our assumption is false. Therefore, 5 minus 2 root 3 is an irrational number. Question 22. For what values of a and b does the system of linear equations have infinite solutions? For infinite solutions, the ratio of coefficients a1 by a2, b1 by b2, and c1 by c2 must be equal. Equating the ratios, we find 1 over equals 1/4. So a is 4. Also, 3/4 plus b equals 1/4, which gives b equals 8. The values are a equals 4 and b equals 8. Question 23. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle of 50 degrees, find angle OAB. The sum of angles AOB and APB is 180 degrees. So angle AOB is 130 degrees. In triangle OAB, OA equals OB. So angles OAB and OBA are equal. The sum of angles in triangle OAB is 180 degrees. Solving for angle OAB, we get 25 degrees. Angle OAB is 25 degrees. Question 24. Find the area of a quadrant of a circle whose circumference is 22 centimeters. Given circumference 2 pi r is 22. We find the radius r is 3.5 centimeters. The area of a quadrant is 1/4 pi r squared. Substituting the values, we calculate the area. The area is 9.625 square centimeters. Question 24 OR. The length of the minute hand of a clock is 14 centimeters. Find the area swept by the minute hand in 5 minutes. The radius is 14 centimeters. The angle swept in 5 minutes is 30 degrees. The area of the sector is theta over 360 times pi r squared. Substituting theta as 30 and r as 14. We calculate the area. The area swept is 51.33 square centimeters. Question 25. A bag contains 5 red balls and some blue balls. If the probability of drawing a blue ball is double that of a red ball, determine the number of blue balls. Let the number of blue balls be x. The total number of balls is 5 plus x. The probability of blue is x over 5 plus x. And red is 5 over 5 plus x. Given probability of blue is twice probability of red. We equate and solve for x. There are 10 blue balls in the bag. Question 26. Prove that square root of 5 is an irrational number. We use proof by contradiction. Assume root 5 is rational. Equal to a over b where a and b are co-prime. Squaring both sides. A squared equals 5b squared. Meaning a is divisible by 5. Let a equal 5k. Substituting back, we find b squared is also divisible by 5. This contradicts that a and b are co-prime. Thus, square root of 5 is irrational. Question 27. The sum of digits of a 2-digit number is 9. 9 times this number is twice the number obtained by reversing the digits. Find the number. Let the number be 10x plus y. We have x plus y equals 9. Also, 9 times the number equals 2 times the reversed number. Simplifying, we get y equals 8x. Substituting into the first equation, we find x is 1 and y is 8. The number is 18. Question 28. Prove the given trigonometric identity involving tan and cot. Convert tan and cot to sine and cosine. Simplify the fractions to get a common denominator. The numerator becomes a difference of cubes. Factorizing and cancelling terms, we get 1 over sine cos plus 1. This simplifies to secant theta cosecant theta plus 1. Proved. Question 28 OR. If sine theta plus cos theta is root 3, prove that tan theta plus cot theta is 1. Squaring the given equation, we find that sine theta cos theta equals 1. Now, express tan theta plus cot theta in terms of sine and cosine. It simplifies to 1 over sine theta cos theta. Since sine theta cos theta is 1, the expression equals 1. Proved. Question 29. A tent is in the shape of a cylinder surmounted by a conical top. Find the area of canvas used and the cost. The radius is 2 meters. The total area is the curved surface area of the cylinder plus the cone. Using the formula 2 pi rh plus pi rl and substituting values, we get 44 square meters. Multiplying by the rate of 500. The total cost is 22,000 rupees. Question 30. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. Find the total surface area. The total surface area is the SA of the cylinder plus the CSA of 2 hemispheres. The formula is 2 pi rh plus 4 pi r squared. Substituting height 10 and radius 3.5. The total surface area is 374 square centimeters. Question 31. The mean of the distribution is 53. Find the missing frequency P. First, find the class marks xi. Then calculate fixi. The sum of frequencies is 72 plus P. The sum of fixi is 3340 plus 70p. Equating the mean formula to 53 and solving for P. The value of P is 28. Question 32. A train travels 63 kilometers at a certain speed and then 72 kilometers at a speed 6 kilometers per hour more. total time is 3 hours. Find the original speed. Let original speed be x. Time taken is distance over speed. The sum of times is 3 hours. Setting up the equation and solving the quadratic equation x squared minus 39x minus 126 equals 0. The original speed is 42 km per hour. Question 32 OR. Two water taps together can fill a tank in 9 3/8 hours. The larger tap takes 10 hours less than the smaller one. Find the time for each. Let the smaller tap take x hours. The larger takes x minus 10. The sum of their rates equals the combined rate. Solving the quadratic equation, we get x equals 25. The smaller tap takes 25 hours, and the larger takes 15 hours. Question 33. In triangle ABC, the is parallel to BC. Find x given the lengths of segments. Using the basic proportionality theorem, add over dB equals A over AC. Substituting the expressions and cross-multiplying, we get a quadratic equation. Solving it gives x equals 1 or negative 0.5. Since length cannot be negative, x is 1. The value of x is 1. Question 34. Prove that lengths of tangents from an external point are equal. Also prove AB plus CD equals AD plus BC for a circumscribed quadrilateral. First, prove triangles POW and PBO are congruent to show tangents are equal. For the quadrilateral, sum the opposite sides AB and CD. Using the property that tangents from a point are equal, group the terms to form AD and BC. Hence, AB plus CD equals AD plus BC. Question 35. The angle of elevation of a cloud from 60 meters above a lake is 30 degrees. And depression of its reflection is 60 degrees. Find the cloud's height. Let the cloud be h meters above the observation point. The reflection is 60 plus h meters below the lake surface. Using tan 30 and tan 60, we form two equations. Solving for h, we get 60 meters. The total height of the cloud is 120 meters. Question 35 OR. The angle of depression of a car changes from 30 to 60 degrees in 6 seconds. Find the time taken to reach the tower. Let the height be h. The distances are h root 3 and h over root 3. The distance covered in 6 seconds is 2h over root 3. Calculating speed and then time for the remaining distance. The time taken is 3 seconds. Question 36. Case study 1. Veer wants to reduce his race time from 51 seconds to 31 seconds. Improving by 2 seconds each day. This forms an arithmetic progression with first term 51 and common difference minus 2. We need to find n when the north term is 31. Solving the AP formula, we get n equals 11. He needs to practice for 11 days. Question 37. Case study 2. Check if the points A, B, C, and D form a square. Calculate the lengths of all 4 sides using the distance formula. All sides are equal to 3 root 2. Next, calculate the diagonals AC and BD. Both diagonals are equal to 6. Since sides are equal and diagonals are equal, ABCD is a square. Question 38. Case study 3. Find the median height of 51 girls from the given data. Total n is 51. So n over 2 is 25.5. The median class is 145 to 150. Using the median formula with lower limit 145. Cumulative frequency 11. Frequency 18. and class size 5. The median height is 149.03 centimeters.